Muy buenas tardes con todos ustedes. El día de hoy tendremos la ponencia de la empresa Anglo Peruana Terra, liderado por el señor Les Oldham, que es geólogo egresado de Royal School of Mines, Imperial College of Science and Technology, Universidad de Londres, UK. Habiendo obtenido el grado de QP, cuenta con 56 años de experiencia en geología de superficie, subterránea de exploración, perforación diamantina, geología regional, cartografía geológica, interpretación de estructuras, geoquímica, exploración de petróleo y gas, consultoría minería y de exploraciones. He is geologist, graduated from the Royal School of Mines, Imperial College of Science of Technology, University of London, UK, having obtained a degree of QP. He has 56 years of experience in surface geology, underground geology, exploration, diamond drilling, regional geology, geological mapping, structural interpretation, geometry, oil and gas exploration, mining and exploration consulting.
We have an exclusive audience here today. Good afternoon, everyone. Today I'm going to talk about mines in Peru. This is from my personal experience. I first came here 35 years ago. And I came here at the invitation of Mark Rich, which is now Glencore. But first of all, I'm going to start in England because this is where I started. But we're going to talk about Ireland first of all, and Ireland is here. In 1968, a student geologist called Mike Russell presented this map for publication, and, excuse me, in his first map in 1968, he put a couple of geofractures, or he called them geofractures, more or less north-south, down the centre of Ireland, and this was connecting various mines and prospects. And there were two lines in his paper of 1968. In a subsequent paper that he published in 1969, he put a third line on the map, which is the one on the right-hand side. He didn't have any reason to put that line on because there's no mines along it, but on geological reasons, he said that there should be, and maybe would be in the future. In 1972, when he finished his PhD, he included this map. This map included the two vertical lines that were originally on and the one without a mine on it, but this time the Terra mine at Navan had been discovered. It was discovered in 1970. So Mike Russell predicted the Terra mine, or the location of the Terra mine, at least 1 year before it was discovered. And it was on an intersection between this north-south line and another line which was going northeast, which was parallel to the regional trend. When I came here, first of all, it was to the Peruana mine to evaluate it. That's a close-up. It's on the Carretera Central. Lima's here, and this is the Carretera Central. You'll notice that the Carretera Central here has a deflection in it, which approximately is northwest-southeast. The red circles are the positions of the ore bodies, as they were known when I arrived there. This is a map of the geochemical map of zinc in float, or base of scree material, and you'll notice it has an orientation of more or less west-northwest, east-southeast. Looking at the first map that I was... Sorry.
Just stand in the right side, please.
Okay. Yeah. This was the first geological map that I saw of Perubar. I noted the things I noted first were a north-south line here, and another one here. There were also lines trending northeastwards, and there was a west-northwest line here and here. Looking closer at the ore bodies, we found a number of other lineaments. One of which here formed the back wall of the Graciela open pit, and also the back wall of the Juanita deposit here, both of them west-northwest. Also, there were dikes, one of them here cutting the Juanita ore body, and another one here cutting the San Cecilia North deposit, which had a trend of more or less 300 degrees or 120 degrees. So this was the distribution of the ore bodies when I got there. With some modeling, this is what the distribution was primarily, because there have been movements, textural movements on these northeast faults. A PhD published by Mark Pollyand in 2006 showed a pullabart basin. This was his model here in the middle, sorry. Here in this one here. And you note that because of the breccias in this area, it was almost certain that these faults were active during sedimentation. Perubar is a VMS deposit, so it was deposited at the same time as the host rocks. On the basis of the lines I'd seen on the previous map, I put a north-south line from Perubar, and it went to Palma. This is a map of the Palma area. You'll notice that on this map, I've put a 120-degree lineament here, which controls the quebrada, and also it forms the northern limit of the Palma ore body, which is also VMS. Looking over here, due north from here is Perubar. So this is probably the line of that was active during sedimentation. And you'll notice in the stratigraphy here, the limestones do a displacement here along this north-south structure. Next, I put a line on the map because of the back wall of the Juanita deposit and also the dike trend. And it took us to Maria Teresa and also to the extension in the extension of the line is following the coastline to the west of Huaral. This is a close-up of the Maria Teresa ore bodies. We have a west-northwest structure here. It's called Fire 120 for obvious reasons. But also there's a north-south fault here, which at the time we mapped it up there, but it's equally likely that this fault goes due north up here. It can't be tested here because it's underneath the tailings dams. This is the distribution of ore bodies at Palma. You'll notice that there's a maximum radius from the intersection of the north-south structure and Fire 120 of 1.4 kilometers. And that distance is sort of not far off a maximum for the extent of mineralization from these centers. Also, if you notice the lineation or the long axes of all the little ore bodies, here it's 320, here it's 330. And we think the reason for that is because these represent Riedel shears and tension gashes related to dextral movement along Fire 120. I've put an arrow up here, and you'll notice that there's a valley here and a valley here that appear to be offset. And you'll see here that there seems to be something that might be offsetting it. That's a close-up. DEM is very useful. DEM often teaches you things that you can't see on the geology maps or on the topographic maps. In fact, there's a project at the intersection of this line called Pampa Virgo, and it's clear from this that there was dextral movement along this line, the 120-degree line, parallel to this one here. The model we came up with for Perubar, based on this, the Pampa Virgo deposit, is first of all an intersection between north-south and 120, dextral movement along the north-south fault, followed by reactivation of the 120-degree fault, causing a small pull-apart basin. And the number 4 here shows how we can explain the northeast faults, because we couldn't find any reason for them except to know that they were moving during sedimentation. So this model seems to hold up, and we use that quite a lot when we're looking for ore bodies. So that's the story so far. And in this diagram, I've put a north-south structure here from Perubar, although you can't see it very well. Perubar is more or less surrounded, surrounded on 3 sides by the coastal batholith. The next mine I studied in detail was the San Vicente mine. You'll notice that the San Vicente ore bodies are lined up north-south. These are believed to be basin margin faults. Also, there are 120-degree structures coming through here. These are mapped in the mine. Slightly different in the north, but basically generally the same direction. And here, this was the map in 1996, not very long, about 9 years after I arrived here. And this is the map from 2016 showing the ore bodies in the southern part of the deposit lined up in a 120-degree direction, which implies that the feeder structures were controlling that mineralization. This is the north is to the left on this slide. And what's interesting here is you'll see 2 vertical lines here. And this is the limit of the San Vicente feeder system, because leads in this area are highly radiogenic. If you go further to the north, to the left, or further to the south, to the right, the leads become non-radiogenic. So here we have an idea where the fluids came in, because the center had to be somewhere right in the middle there. This is another one, the same one repeated on the left-hand side, the 2016 map. And on here I've put north-northwest 120-degree lines where they coincide with ore bodies and where they coincide with mapped faults in the mine. And they're really quite regular. And there's a difference in characteristics here. The mantos to the north and the ore bodies lined up along a northwest direction to the south. I've marked a line on here called the Los Perdidos San Vicente line, which is 120 degrees, and we believe that is the initial source at depth of the mineralizing fluids. And it's exactly in the middle of the 5-kilometer width of the mineralizing system, which is here. And you'll notice that the extent of the main part of the mineralization, this red line here, denotes where the richest parts of the mine were exploited. And even now, they're discovering mineralization further down in this direction. So we expect San Vicente to continue along this line. And this is just to make it easier for you to see the 1 kilometer on either side. Sorry about that. 1 kilometer on either side of the Los Perdidos San Vicente line. Okay. Because of the west-northwest trending faults in San Vicente, which were extremely common, we decided to look what would happen if we extended it to the northwest, or the west-northwest. And we came across a line, a very interesting line, because you'll notice it slides past the northern edge of the Lake Junín Basin, and further to the left, you'll see the Pampa de Lampas Basin is terminated at its southern edge. So there is geological and geomorphological evidence for that line to exist. Because all these lines are imaginary. You can't actually see a fault along most sections of that line. And that line is exactly 120 degrees. Also, along the line, there are other ore bodies. Shalipaiko here, Kolki here aquí, and Raura here. Shalipaiko looks a little bit displaced, so let's have a look at Shalipaiko. Shalipaiko ore body is here. The line that I'm suggesting may be a feeder comes here to the south, but you'll notice there's a lot of lineaments here picked up off satellite imagery going north-south. And also these blue lines here represent faults mapped in the field. So it's possible that the feeders came from here and came up to here. And the next slide shows where we are between the feeder system, which we believe is this one, and the outcrop, which is up here. So it's quite possible that there's much more mineralization, more tonnages and more better grades closer to the feeder system. On this map, I've put on other deposits which have been found since we put the line on the map originally. Kikai and Yumpag are exactly along the line, as is Los Perdidos. Los Perdidos is a VMS. Nexa is the owner of it, and it's going to be drilled this year. Noting that this line formed the northern boundary of the Lake Junín Basin, we thought that there might be something down here. On this one, I've just included the north. In all of these deposits, except Kikai, we can see north-south trending structures, which imply that the ore deposit lies at the intersection of these two lines. When we put the line on across the base, the southern margin of the Lake Junín Basin, we find that 3 deposits lie on it. Elida here, Iskai Cruz here, and Huaron. At Huaron and Iskai Cruz, there's not as much evidence for north-south lineaments, but it does line up with Raura, for example, that one. And this one lines up with Kikai. Can you hear me? No problem? Good. Elida's interesting also because it has the same type of dextral movement along the 120 if that line actually exists. So it's very similar to Perubar, which has this, and Pampa Virgo, which have the same characteristic. Then we did some work at Atacocha, and we found that it was on a north-south line. The Milpo-Atacocha line here. And the ore bodies here are spread out to the right and to the left of the north-south line. But what is interesting is this area here seems not to be part of this. It seems to have been displaced. And also the ore bodies here, the Cuerpo San Gerardo, are much further to the northeast than here. What we decided had happened, there was 500 meters of sinistral movement along the Milpo-Atacocha fault since 30 million years ago when these deposits were laid down. And this is the actual position they were in when these deposits were formed. And I've put a 120-degree line there because there's a fault of 120 degrees, and all the intrusives here line up along that lineament. Also, further to the south, APT worked on the Domo de Yauli area in here, and you'll notice that the mines of Yauli-Yacu, Waripampa, San Cristobal, and Naichagua, Trapiche, and Zoraida all lie along that line. That line is slightly displaced. All the other lines in this presentation are exactly 120 degrees, but this one's slightly off. And this is an important point because although these imaginary lines probably are correct at great depth, the further closer to the surface they come, the more likely they are to deviate from the original orientation of the main structure at depth. Okay, out of the last image, I'm going to pick this line here from Iskai Cruz to Yauli-Yacu. Why? Because there are mines and prospects lined up along that line. It's a straight line between Iskai Cruz, more or less, and Yauli-Yacu. Moving south, there's an old series of trials. That belongs to Pan American Silver. They haven't looked at that very closely yet. Santander, that's a working mine. Victoria, it's a small mine. It was working recently. It's now closed for scale, but it's being explored. Ariana, a copper project from Southern Peaks. And Yauli-Yacu, which used to be owned by Glencore. In detail, you'll notice, I don't know if you can read it, but the distance between these west-northwest trending lines are 10.6, 9, 10.1, 10, and this one's 13.7. But the source of the main feeder for Iskai Cruz might be a little bit further to the south. You'll also notice that from Iskai Cruz in this direction, you come to Waron. South of Waron, you have the Animon mine. Santander mine is here. Further along the lineament is the Alpamarca mine and plant. And that sort of sums it up. All of these are along 120-degree structures. That makes it a little bit maybe easier to see. So that's the full story in this area for the moment. The next place we did some work was in Uchuchacua, and you'll notice that there's a northeast trending line trending from Uchuchacua to Yumpag, a new discovery, and it ends up at Ayawilca, at an intersection with the west-northwest trending structure from Atacocha. So Ayawilca seems to be controlled by two different lines. Well, one's the 120, it's the same as all the others, but this line here, and we need to consider if that line is valid, and also if this line is valid. The thing is, between Uchuchacua and Yumpag, there is a fault which has been mapped on surface, the Cachipampa fault, and that could explain this line, but we don't know if it's a deep lineament. And the reason for that is, if you look at this diagram here, I've put circles on all the intersections between north-south and 120-degree structures. And you'll notice when you look at that, there's an apparent line going south-southeast, which corresponds in orientation to the line that was on a previous map between Iskay Cruz and Yauliyacu. And also, this line here is very similar in orientation to the line between Uchuchacua and Ayawilca. But the thing is that all of these points marked in solid circles, green, all of them lie on this south-southeast line, but they lie on those lines maybe because they're at intersections between north-south and 120-degree structures. So it's not clear that those two lines exist, but at the same time, maybe they do. The one from north-northwest to south-southeast agrees with the Andean trend. Okay, moving on, Cerro Lindo, VMS. And when you look at Cerro Lindo in relation to what's around it, you can see from Perubar, we went to Palma earlier. If you extend the line to the south, it comes to Raul Condestable. If you extend a northwest trending line from Cerro Lindo, it also comes to Condestable. And further to the south, El Carmen, which is a project involving Nexa. There's a group of VMSs there which more or less lie on the 120-degree structure. This is the geochemical anomaly, copper, at Cerro Lindo. So the trend of that is more or less west-northwest or 120 degrees, but you wouldn't draw a line through that with much certainty. But when you look at the regional geology, you'll notice that the contact between the coastal batholith to the south and the Casimir equivalent here, which are dacites and rhyolites, the contact between the two is exactly 120 degrees. And if that's extended eastwards, you come to the ore bodies at Cerro Lindo. There's also hints of north-south faults here, but we have even better evidence for that. This is a close-up of the Cerro Lindo deposit, and in purple are all the known ore bodies so far. They stop at a line which trends northeast-southwest, and also what you might note is there may be a circular structure in here. This shows it better, the ore bodies in purple, the circles representing something. We think it's a rhyolitic dome. And also another lineament, the Pukasala Sur lineament, on the other side of the circles. The geochemical anomalies for copper are marked in red, and you'll see they go around the circle, the rhyolitic dome, and go off to the northwest in this in this direction here. So it's lining up along a northwest trend. Another thing to note is late dikes, which cut the ore bodies. Here, you'll notice the dikes are deflected here along the Toparo lineament, and then they go back and they continue north-south. There's a north-south dike here that also is deflected around the dome, But then you can see further up it goes, just a minute, here, and then back up north too. So something there is making these dikes avoid this center. And maybe it's stopping the mineralization from getting through there as well. So obviously the intersection between the west-northwest trend and the lineamiento Pucasala Sur might be a good place to look for additional mineralization. You'll notice in the orientation of the veins here, it's slightly, there you go back. The orientation of the veins are 130 degrees and not 120. And that links in with what we know from Maria Teresa, where all the ore bodies had long axes along the rhydal shear and tension gash trends. So it's a similar story. Okay, so that's all of the lineaments. And what I've done here is taken out everything else. This is part of GMAP, which Anglo Peruana produced. And here, on the right-hand side, again, hold a second, you'll notice that there's often geological backup for these lines. Here, you've got basement, then Pukra and Mitu and basement. Obviously, this line is controlling geology. And this one here, you'll see that here you've got volcanics, here you've got intrusive. So apart from topographic controls, there are geological controls also. I thought we'd better mention copper because it's one of the most desired metals at the moment. And you'll notice that Cerro Verde, Don Javier, Cuajone and Quellaveco are all on one line, which is exactly 120 degrees. Chapi is on another line, 120, but also at an intersection between with a north-south trend. Also, Quellaveco and Toquepala are on the intersections between north-south and 120-degree structures. And if you're in any doubt that these 120-degree structures are important, if you look at the distribution of salt domes in the north of Peru, you'll see that they line up along 120-degree, 300-degree line. And there's also a hint of a north-south trend here. The northwest trend also defines these lines, which are straight line part of the coastline. You'll notice here. Coastline and coastline here near Waral. So, why do some mines and prospects in Peru lie along imaginary straight lines? From my point of view and from Anglo Peruana's point of view, these imaginary lines are real, but only real at depth. You can't see them in their, or you can rarely see them in their correct position at surface, because the closer you get to surface, the more opportunities there are for these fractures to splay and change direction. So they're not easy to spot, but if you can spot them, it's very useful, because as I showed you, the radius with the radius defining the circle containing all of the ore bodies is usually no more than 1.5 or 2 kilometers. So if you can recognize these lines, then you've got a fairly good chance of putting your first borehole more or less where it's got the best chance of finding something. And that's it. So you can ask questions. if you have any. Okay, this idea is based on facts. All these mines exist. Their position is very accurately defined. So really the best way to find where these lines are is look where the mines and mineral occurrences lie. If you remember right at the beginning, I showed you the north-south line, which was predicted, which was drawn before Navan ore body was formed. No other mine has been discovered yet along the extension of that, and that's more than 30 years ago. So it may not be necessary or even easy to define these lines exactly, because I've only showed you part of Peru. They occur in other parts of Peru and in Ecuador and in Chile. But when you can identify them, and there are ways of doing it, and you know that from an intersection between a north-south line and a west-northwest line, you have a point, the radius of 1.5 to 2 kilometers is probably the maximum distance for that cell. This implies that very deep structures can affect movement of fluids, and that these fluids tend to find their way almost vertically to the place where they're eventually deposited in whichever horizon they're deposited. So it's predictive in a way, but it's better used as a fine-tuning thing, because if you've got an anomaly, if you've got all the characteristics, but you don't know where to drill your first borehole, the first thing you do is you look for a west-northwest, east-southeast line and a north-south line, and then you put your first borehole as close as possible to that intersection. And
some of your maps, some of these lines in a certain spacing. What do you think controls that spacing?
The depth. I think the max, possibly, it's very difficult to know actually, but for example, 10 kilometers, which was the distance between the occurrences between Yaoliaku and Iskai Cruz, they were almost exactly at 10-kilometer intervals. But at San Vicente, I put lines on which were controlling mineralization, which were only 430 meters apart. At Parcoy, the Mina Gigante de Marsa and the Parcoy mine, they're also on 120-degree structures, and their mineralization is spot on, within a kilometer on either side of the intersection between these lines.
In my experience, when I do regional scale compilations of structures, what I do occasionally, I sometimes find that actually these deep-rooted lineaments that are probably basement faults, they can show as corridors of parallel, often fairly short faults and geological contacts, tectonic contacts. They are rather corridors than well-defined lines. And sometimes you can even find not only aligned ore deposits, but also an alignment of magmatism. So
yeah.
I think this is a very, very good guide to identify those deep basement structures.
Yeah, I suspect that these imaginary lines that I've been showing you are only in that position at depth. When they come up close to surface, they try to go through, but so many things can happen near to surface, thrusting, faulting. I don't think the deep structures move very much. I think they're always there. So those are always the places where the fluids tend to concentrate. But yes, in surface, they've got more opportunities to change direction, move outwards, and form multiple lines. So it depends which level you're looking at. For example, in northern Scotland, there's a fault which cuts the Dalradian, which is way Precambrian, and it's in a dead straight line. But you can't find any other straight line like that one in Scotland in higher strata. They tend to split up and become less easy. But in recognizing the position of these lines, we use topography, because often rivers and streams are offset, so the valley becomes offset, like at Peruana I mentioned. So that's one of the tools. The linear coastline, stretches of linear coastline, they seem to line up. If you remember Peruana and Maria Teresa, that line continued in a very straight part of the coastline. So there are ways of finding them. And this is what we try to do in Anglo-Peruana, because we think that if you drill as close as possible to one of these lines, or intersection of two of these lines, I should say, you've got a better chance of hitting what you want to hit with the first borehole. And that's always satisfying. There was a question over there.
Yes, thank you, Les, for the presentation. I have a question. What kind of other geological features could be related to these lines? For example, in the Peruvian porphyry copper belt in the south, we have the Sinchayuta Incapuquio fault that is one of the main controllers of the porphyry copper mineralization in that part. But in other parts, for example, these lines could be related to what kind of other geological features, like magmatisms or dome corridors, or maybe salt diaperams. So there are other kinds of examples that maybe could be more intendable for other belts here in Peru.
I think so, yes. Working out where these lines are here, if you look at satellite imagery, you can get the impression, and you can see faults that line up against there. For example, at Cerro Verde, the back wall fault on the northern side is exactly 120 degrees. And that continues. You continue the line and you come to Quajone and Quellaveco. So there are things, but the thing is, it's usually when these deposits are mined that you see the control, and then you know it's on the line, but the line didn't find the ore body. Maybe geochemistry found the anomaly, which you eventually drilled and found a deposit, and then you realize it's on one of these lines. So it is predictive, but it's probably not it's an additional tool. If you know about it, it's good.
Thank you.
No more questions. Thank you for listening.